In the quiet moments before sunrise, something extraordinary stands ready. Not just a rocket, but a statement. China's latest lunar launch system isn't just another step in space exploration. It represents a leap in ambition, engineering, and global power. For decades, the world watched as others led the charge to the moon. But now the balance is shifting. What you're looking at is the result of years of relentless innovation, a machine designed not only to reach the moon, but to redefine how we get there. Behind its polished exterior lies technology that has captured global attention, raising eyebrows in laboratories and command centers far beyond China's borders. But what exactly makes this rocket different? Why are experts beginning to speak in quieter tones, with a hint of urgency? As countdown approaches, one question hangs in the air. Has China just changed the rules of the moon race forever? Deep inside China's mission control, every second is calculated, every variable accounted for. This is where the real power of the mission becomes visible, not just in hardware, but in intelligence. The systems guiding this rocket are built on next-generation computational models, capable of adapting mid-flight with remarkable precision. Unlike traditional launch systems that rely heavily on pre-programmed sequences, this rocket introduces a new level of autonomy. It can respond to changing conditions in real time, adjusting trajectory, optimizing fuel consumption, and ensuring maximum efficiency on its path to the moon. This level of responsiveness isn't just impressive, it's transformative. It means fewer risks, higher success rates, and a level of control that pushes beyond conventional limits. Around the world, space agencies are taking notice. Because when a rocket can think, adapt, and optimize itself during one of the most complex journeys known to humanity, it's no longer just a vehicle. It becomes something more. And that raises a critical question. If this is the future of spaceflight, who is truly leading the race now? Then it happens. A controlled explosion of power ignites beneath the rocket, releasing a force so immense it shakes the ground itself. This is not just liftoff, it's precision unleashed. The engines powering this ascent represent a significant advancement in propulsion technology. Designed for higher thrust and greater efficiency, they push the boundaries of what modern rocketry can achieve. But it's not just about power, it's about control. As the rocket climbs higher, its systems continuously adjust, maintaining stability despite extreme forces. Every movement is calculated, every second optimized. This is where engineering meets mastery. The margin for error is almost non-existent, yet the rocket moves with confidence, slicing through the atmosphere as if guided by an invisible hand. For those watching closely, this isn't just another launch. It's a demonstration that China has entered a new phase of capability, one where innovation is no longer incremental, but exponential. And as the rocket disappears into the sky, one thought becomes impossible to ignore. How far ahead has this technology really gone? Beyond Earth's atmosphere, the mission reveals its true sophistication. Stage separation occurs with flawless timing, each component performing its role with surgical precision. This is where efficiency becomes everything. The rocket sheds weight, optimizes structure, and transitions seamlessly into deep space travel mode. But what makes this phase remarkable isn't just the mechanics, it's the integration. Every system is interconnected, communicating constantly to ensure optimal performance. From propulsion to navigation, from energy management to thermal regulation, everything operates as a unified whole. This level of integration reduces failure points and increases mission reliability. It's a design philosophy that prioritizes resilience and adaptability. As the spacecraft continues its journey, it becomes clear that this isn't just about reaching the moon. It's about doing so smarter, faster, and more efficiently than ever before. And that raises an important question. If this level of precision becomes the new standard, how will others keep up? One of the most overlooked aspects of space travel is also one of the most critical: materials. The extreme conditions of launch, space travel, and lunar operations demand more than just strength. They demand resilience at a microscopic level. China's rocket introduces a new generation of materials engineered to withstand intense heat, pressure, and radiation. These materials are lighter, stronger, and more durable than previous designs. But more importantly, they enhance performance. By reducing weight while maintaining structural integrity, the rocket achieves greater efficiency without compromising safety. In testing facilities, these materials are pushed to their limits, exposed to conditions that mimic the harshest environments known to space exploration. And they endure. This advancement may not be as visible as a rocket launch, but its impact is profound. Because in space, every gram matters, every degree counts, and every improvement can mean the difference between success and failure. And with this level of material innovation, China isn't just improving rockets, it's redefining what they can survive. As the spacecraft nears its destination, the challenge becomes even more complex. Landing on the moon is not simply about descent. It's about precision under pressure. China's approach introduces advanced landing algorithms capable of analyzing terrain in real time. Using high-resolution mapping and onboard sensors, the system identifies the safest possible landing zone, adjusting its descent path accordingly. This reduces risk and increases mission success rates significantly. But there's more. The landing system is designed to be autonomous, minimizing reliance on delayed communications from Earth. This means faster decision-making, greater adaptability, and a higher margin of safety. In the final moments before touchdown, every calculation matters. The spacecraft must balance speed, stability, and positioning with near-perfect accuracy. And it does. As the lunar surface comes into view, the significance of this moment becomes clear. This isn't just a landing, it's proof. Proof that the technology guiding this mission is capable of handling one of the most difficult tasks in space exploration. And if this capability continues to evolve, it raises a powerful question. What comes next? Footsteps press in a lunar dust once again, but this time they carry a different meaning. The presence on the moon is no longer symbolic, it's strategic. Every movement, every piece of equipment deployed reflects years of preparation and technological advancement. The suits worn by the astronauts are designed for flexibility, durability, and extended operation. Communication systems ensure constant connection, while life support systems maintain stability in an environment that offers none. This mission is not just about arrival. It's about capability, the ability to operate, explore, and potentially build. Because the moon is no longer just a destination, it's becoming a platform for future missions, deeper exploration, and perhaps even long-term presence. As the flag stands against the stark lunar landscape, it signals more than achievement. It signals intent. And for observers back on Earth, one reality becomes increasingly clear. The competition for space dominance has entered a new phase. Back on Earth, the reaction is immediate but controlled. Within China, The mission is analyzed not with celebration alone, but with precision. Every metric is reviewed, every success dissected for further improvement. This is not the end goal, it's a checkpoint. Because what has been achieved here is not just progress, but acceleration. The systems performed beyond expectations. The technologies validated under real conditions. And that creates momentum. A momentum driven by strategy, discipline, and long-term vision. The speed at which these advancements are unfolding suggests a coordinated effort, one that goes beyond individual missions. It points to a broader objective, leadership, and when progress becomes consistent, predictable, and scalable, it changes the global equation entirely. Because in a race defined by innovation, momentum can be the deciding factor. The implications of this mission extend far beyond a single landing. What you're witnessing could be the foundation of something much larger. Plans for lunar bases, resource extraction, and deeper space missions are no longer theoretical. They're becoming tangible. The moon could serve as a gateway, a testing ground, and a launch point for journeys even further into space. And with each advancement, the gap between vision and reality continues to shrink. This is where strategy meets innovation. Because whoever masters this stage of exploration doesn't just lead, they define the future. The infrastructure being imagined today could become the reality of tomorrow. And if this trajectory continues, the next era of space exploration may not be led by those who started first, but by those who adapted fastest. What began as a single launch has evolved into something far greater, a signal. A signal that the next chapter of space exploration is already being written. Not in theory, but in action. The technologies demonstrated in this mission are not just improvements. They are indicators of a new direction. A direction where innovation moves faster, systems become smarter, and ambitions grow larger. The moon is no longer the end goal, it's the beginning. And as the world watches, one thing becomes certain. The race for space is no longer what it used to be. It's faster, more competitive, and more unpredictable than ever before. The question now is simple, yet profound. Who will shape the future beyond Earth? Subscribe now and stay connected as we uncover the next breakthroughs shaping the future of space, technology, and global power.